Someone please confirm in chat or just saying.
Hello, yes, we can.
Yeah, okay, perfectly. Okay, so as you can see a definition here. We have this handling. The grippers are the handling mechanism, and that what we have is this temporary contact with the object, and what we are also expecting from the gripper is that we keep the certain position and orientation when the object is carried. So what we also have is that sometimes we use the term gripper not only in the case when we grasp an object, but also for other ways of holding an object, like vacuum suction, retention force. I don't know why spaces has disappeared in this text. I need to check what's happened. Okay, so let's talk about the grippers. I think that there will be some basic elements that you probably know at the beginning, but also will show some elements, some examples that may be more interesting to know that such a solution exists. So firstly, what task the grippers can be used for? So of course, they are all related with transport. And this the whole transporting object with the grippers consists of the 4 elements that we have. So the first is prehension. So we need firstly to attach the gripper to an object somehow. We will tell later about the methods. Manipulation, that should be in fact in parentheses, because sometimes we are able to manipulate with an object and sometimes we are not. It depends on the degrees of the freedom of the gripper and of the construction. For example, with suction gripper, we have no option to manipulate it, but if we have multi-finger grippers, then such option exists. So manipulation is changing either position or orientation of the object that is already in contact. So we can rotate it, we can somehow move it to grasp it better, to have a better contact for all the transport tasks. Then we have the movement, and usually what is the task of the gripper in that phase is just keeping the connection stable, so the object is not released during being moved from one place to another. And finally, the placement. So we need to release the object in the destination. And so those are the tasks during the process. And so what are the functions that the gripper keeps? Is firstly, it maintains the position and orientation of the object with respect to the gripper and the equipment. Why we say about equipment? For example, when you want to place an object at let's say at final position, it may be necessary that you get a precise position or precise orientation. If you, for example, want to put it in CNC machine, or or in a storage area, you may be required to either get a very precise position or orientation. Also in the let's say assembly task, you also need to get a proper position and orientation, not only with respect to gripper but also to other equipment. Then applying static or dynamic forces that can be used, for example, in assigning parts or in the assembly task, when you not only you are not only interested in the static position of the object, but also with the forces that are applied through this object or by this object. On the force control, we will be talking yet probably in 2 lectures from now. So it is just the point to be remembered that also the force control can be applied not only directly by the tool, but also via the object. And then performing operation with the gripper or with an object connected to the gripper. Okay, so that's just I think quite obvious. So what are the requirements? So of course the first requirement is that the gripper is able to do the operations that we mentioned on the previous slide. But when you select a gripper, you need to take into account also other parameters. So the weight of the gripper itself and the weight of the objects that you are going to carry, because all the robot has certain limits on the load that they can have. Then the dimensions, again, dimensions of the objects, dimensions of the gripper, that you must be able to perform the operation and take into account the place that the gripper itself will take. Then the forces. Yes, if you want to, let's say, if you want to use like suction gripper, the vacuum gripper, and you have a heavy object, you need to know of what force you need to generate to be able to keep that object, both in the static situation, so when you are stopped, but also when you are moving, and the forces also change. Then the sensors that you need to have in the gripper. Of course, you can have grippers that are simple, having no sensor at all. They can have simple sensors like detection if the object is present at all, but also they can be some quite complex grippers with full measurement of the force in all dimensions, so both linear forces and angular as well. And finally, as with all elements, that we have the reliability, so how effective and how well the gripper works. Okay. So let's, as usual, we will begin with some classifications, and we'll say what are different criteria of classifying the grippers. And so firstly, first of the criteria is the construction, so how the gripper is built. Then the functional features, so what the gripper is able to do. Then the grasping type, when we'll say about the graspers. Some also additional equipment and mounting systems. And we'll go through these criteria one by one. So let's say about the construction. So firstly, first element of the construction is the actuation type. So depending of how the gripper is actuated, you can have pneumatic grippers. That kind of the grippers you can in fact observe in the laboratory with 010 when you have a project. You can have electric grippers, hydraulic or adhesive. And maybe the last one is not quite clear of what it is, so just wanting to show you the example. Of how it works. Let's switch to another screen, and yeah, that's the way how the adhesive grippers work. It just uses the generated adhesive force as similar to the vacuum gripper, but the operation is a little bit different. Okay. So I just need to switch. Okay. Returning to the here, we can also have another element of the construction is the drive transmission. So we can have different methods of transferring the force from the motors or from the source of actuation to the tips of the gripper. So we can have belts or chains. We can have levers or spurgers. We'll show later some examples of the specific grippers, so you will see how they can work. And finally, we can have the different effector fingers. Some of them, they can be solid, some can be resilient or elastic. And while the solid grippers, you probably know how they look like. I would like also to show what are the resilient and elastic grippers as well. And to show that, I just need to switch to another window again. And we will go to that point, but okay, so firstly, let's say about the resilient one. So this is the example of how the resilient gripper works. We'll see in a while how it looks during the operation. So as you can see, the elements that are here, it uses the elasticity of the tips of the gripper just to make the movement. And now you can see also the fully elastic gripper. That's one of the element of the project that was made by the students from our university. That's the so-called TRACH project. What was specific, it was done in a let's say closed space, so in the zero gravity condition, using the European Space Agency REXUS program. So the goal of the project was to test how the elastic grippers will operate in space when there is no gravity conditions. But we can also look at some other elastic grippers, and just to get to them, you can see this example. In fact, that was the gripper that was the inspiration for the Trudge project. And the idea of the gripper is that it is fully elastic, filled with some powder. When it just moves, it just fits with the shape to an object. Then the vacuum pump is used to remove the air, so the particles inside this bag, they just get closer, so the friction starts to operate and makes the gripper, let's say, semi-solid, and then the shape is preserved and keeping the objects. Then when we get to the final point, we just push again some air into the grippers, so the distance between the particles becomes bigger and the object is released. So, getting back to the point, so solid grippers, when the most typical in industry, resilient when we have the some elasticity of the elements used for grasping, and fully elastic when when the base of the movement is the complete change of the shape of the gripper. Then we can say about the functional features. First of them is the grasping force. We can have the grippers with the constant force. So that was for a long time, it was the industrial standard that, for example, for pneumatic grippers, that the force was the force was resulting from the valve and the pressure of the air in the installation, and you had no options to adjust this force. Then there is a gripper that can be manually adjustable. So there are some manual regulator, and you can determine you can set the grasping force that you want to use, but you cannot do it in your program. So in fact, it is fixed for all the operation, but can be changed when you change the operation and you stop the robot and you reprogram it. You can also change it physically. And finally, the most advanced, the automatic selection of the grasping force, that will probably the standard soon, when it is necessary for modern production to be to ensure this option to quickly change the requirements for different of the line, of what is produced on the line. This automatic change of the grasping force is also becomes the necessity. Then what we also have in functional features is the grip spacing. So what is the range of the object sizes that can be grasped, and the operation time, that the operation time, the important elements are the prehension and the release. Depending on the type of the gripper, they can be different. So for the mechanical gripper, They are usually similar, yeah? So closing the gripper and opening is more or less the same. But if you think about the, let's say, vacuum gripper, it may take longer to create the proper level of vacuum or low pressure to grasp an object, and releasing will be much easier. So those are the features that you usually pay attention to when you select a gripper for your for the task that you are going to do. Then you can think about the additional equipment that you have with your gripper. So there can be sensors. They can be a simple sensor of the proximity, so you detect if there is an object with grasp or not. You can have a touch sensor, so when closing the gripper, you can detect if you really grasp the object already or not. That is especially important when you want to grasp the objects of different sizes or non-symmetric objects from in different orientations. You need to know where to stop the closing the gripper if you don't have, for example, the force sensor. Then you can have the pressure sensor or load sensor, both to measure the pressure that you apply to an object, but also you can have an option to determine the load of the sensor when you carry the object. The load can be important, especially when you use the gripper for carrying bigger objects, because depending on the load, the parameters of the movement can be modified. Yes, so if you have an object that is heavier, you should move with lower acceleration, probably to ensure the safety of whole process. And what you can have as additional elements are some supporting mechanisms, like that move the objects within the gripper, for example, or that help to carry the object. So they can be like rotational, prismatic, or flexible pressure mechanism. And finally, the last element that you want to look at is the mounting system. If the mounting system is manual or if it's automatic. The manual mounting system is something that you, again, probably already know well. So it's just a standard grippers that you usually meet. So you take the gripper, you need to attach it with screws, connect with the cables manually, and only then the gripper is ready to work. But we also have some automatic mounting system, and we can use it for the changing of the tools. And again, I would like to show you the video of how it looks. And we have it here. So you can see a part of the object, but what happens in the back is that you have the tool changer somewhere on the back side, and you can see that the robot can really change its tools, connect to a new tool, and perform a different operation. So as you can see, that's these automatic tool changers can handle multiple different tools. What is important and what you need to be aware of, that in fact this tool changing is quite a complex operation, to be performed, because it's not only a physical mechanical attachment of the tool at the end, but it is also ensuring all the electrical connections and pneumatic connections within between the robot and the tool itself. So the elements that you can have there, these automatic tool changers, they usually provide some connections for pneumatic pipes, multiple electrical connections, electrical lines for inputs and outputs, so we can really control the end effector as well. And as you can expect, the purpose of having the automatic tool changer is that to speed up the process. When the process is complex and you use the same robot for different element of the production process, and you don't want and these elements of the process are interlaced often, so you don't want an operator to change the tools manually, then you use this kind of the automatic tool changers. Okay, so that's about the requirements, and let's go to the different types of the grippers and how they work. So firstly, the main the grasping type, that's something that that's one of the basic difference that you can easily observe when you look at the gripper. So how the gripper works. Most of the grippers that you probably have seen, they are the impactive grippers. So the grasping of the object or keeping the object is achieved by touching it. Yes. So there is impactive force against the surface of the object. So all these multi-finger grippers, but also those elastic grippers that we are observing, they were the examples of the impactive grippers. And then we have the ingressive grippers, not so common to see, but they usually attach somehow to object surface. So they can be either intrusive. This kind of the grippers, for example, using pins is used. You can find the examples in such situations like grasping the foam types objects. So we just use pins, connect, stick to the object and move it. There can be also non-intrusive, like using hooks and loops. Then there is the third type of the grasping is the restrictive grasping, when the force attaching the object to the gripper is produced by a certain field, and it can be either a vacuum, so based on low pressure. It can be magnetism or electrostatic fields. So magnetic grippers, electromagnetic grippers, probably you can easily imagine. Electrostatic, we have already seen on the visit. Okay, we've seen the adhesive. Electrostatic works quite similar. It's usually used to carry the objects of the type of like sheets of paper, like elements that are usually of large area and low mass. So that's kind of the object. And they can be also the constitutive grippers when we have the necessity of touching the objects and having the certain reaction between the objects and the gripper, and there can be adhesion type, so the chemical adhesion or thermal adhesion, or the surface tension. All of these types of the gripper have certain applications. So when you look at the objects, you will probably need to consider the elements at the of this last group. They usually are used for the objects having relatively small masses. The most typical are impactive grippers of the first group, and the third one, especially the vacuum and the magnetic grippers. Okay, as we said, the most typical are impactive grippers, so let's say a little bit more about them, as we will need to know of what different approach to grasping is used. So the main division is the type of the application of the force that keeps the objects within the gripper, and we can divide it here, these impactive grippers, to either shape enclosure or force enclosure. There can be also some mixed solution, but to say about that, we will explain of what shape and force enclosure are. So when you look at the examples here, those are the different types of the grippers. The impactive grippers of the shape enclosure and force enclosure are on the first three types. First two are the shape enclosure type. Here are the force enclosure. So let's explain of what is the case. When we have an object then that we grasp in that way, what happens? We have okay, let's make a quick drawing.
Especially when you have mighties in the team.
So when we have the gripper of that type, what happens? What are the forces? We have the gravity force in here, and we have the force that the gripper applies here on the sides. So why the object is kept within the gripper? The reason why it happens is the friction force that keeps the object between the gripper fingers. So as you probably know, this friction force depends on the friction coefficient and the force applied to the object. So it's like this force multiplied by the friction coefficient. And so that is called the force enclosure. So the basic property that can say of what is the force enclosure is such an grasp type that depends on the applied applied force, and when the force that you apply is too small, or let's say if we have a limited set grasping force, you can always apply such a force to an object that the object will fall and the grasp will not kept. On the other hand, we have the shape enclosure, and the shape enclosure you have on the first two pictures. So you have the object and you have the gripper that has a certain shape that keeps the object. And you can see that there is that the forces that are applied in these situations to an object, like we have it here, come from different directions. So in fact, there is no options that you can apply a force to an object that will move the objects without, let's say, without breaking the gripper itself. So the shape enclosure is in that sense safer because it does not really depend on the force that is applied. It only depends on the correct position of the gripper with respect to the object. And you have two different examples here. One with three-finger gripper with the shapes here at the tip to grasp a ball. Here you have just like two-finger, but one is especially shaped for the object to be grasped, and just the second one is to keep the object. That also ensures that the objects will not fall out of the gripper. So those are the options that we have. Can you probably guess what are the other three types? Maybe just a brief quiz of what can be 4, 5, and 6. Please type in the chat of what you think they are. So what is option 5, or 4, 5, 6? Any guesses? Okay, yeah. First is 4 is definitely vacuum. 6 was more like yeah. In fact, 6 was more like adhesion. The 5, okay, that was just an these cables were to show this electromagnetic. Yes, that's okay. That's a little bit of the suggestion of not only the grasp type, but okay, it's not so easy to distinguish it only by the bottom part, but also, okay, these suggestions with, let's say, cables or a pipe. Yeah, that's so the idea is the vacuum here, that's the electromagnetic here, and any type of the adhesion in that element. So you have the contact element in here that is important, and yeah, those are just the illustrations. And okay, what you exactly have the answers. So it's just pure enclosing with the shape enclosing. Second is the partial form fit, partial because only a part of the gripper is shaped for the object. Then you have this pure force enclosure, vacuum magnetic, and the adhesive. Okay, now just as a second part of yeah, just a very a simple example for you to think about the problems that we meet when we have the grippers. Is just this this element of we just imagine picking up an object. So we have an object of 1 kilogram that is shaped grasp. So we somehow grasp it, let's say, in that way. We have the gripper correctly grasping the object 1 kilogram down. And we want to move the object with the 0.g up. What payload we need to do that? So when you look at the documentation of the robot, how do you calculate the payload that you need? Why 7.5? That's one.
That's good. As one of the professors said, it's better to have some.
Okay. Can you give some explanation? Okay, of the 7.5. I'm pretty.
Yes. I when people see the problem, I see the opportunity.
Pretty much surprised
This
with
is
the answer.
that needs to be solved, right? Come on, this is what we are doing.
Mr. Zatoń? Wait, why 7.5?
Yeah, exactly.
Oh, can you hear me now? Yeah.
Okay, now I can hear you. Yes.
Okay. So maybe it just was a shot, but actually I thought about the force needed to pick up those whole mass, which is 1.5 kilo times the acceleration, which is the 5 meters per second square, if it's half of g. But maybe
okay.
just a shot.
Okay. But what does it mean when you have a, let's say, information that the payload is 5 kilogram on the? So you look at the documentation of the robot and you see something like that. Okay, maybe in the documentation is a little bit more detailed. Let's say in the on the marketing on this marketing brief note. What does it mean? That that information. So you can imagine that you are buying a robot, and that's usually max payload, something like that. For sure, you will find something like that in industrial robots. That usually means that you are able, that the producer says, okay, when you have this robot, and when you attach at this tip, you can attach the 5 kilogram. And the robot is able to carry that. Okay, so this 5 kilogram means the static load, and static load means that you have for sure 1g acceleration of the applied to that object here. We'll make okay, we'll make some disclaimers later. So, but anyway, The assumption is we have 5 kilograms. We have it working in a natural Earth condition, 1g down. So what we have here? Here we have like a 1.5 kilogram of the mass, and we have the force that results from the force that comes from, let's say, that comes from 1g of the gravity and half g of the acceleration of this motion. So basically, that means that we need to multiply everything by 1.5 to 25. Okay, so that's something as we need to think as about the load. Okay, as I said, there will be some disclaimers. So of course, firstly, the first disclaimer is that when the producer says 5 kilograms, of course, it has some, doesn't say it's only a completely static situation. They usually assume certain level of movement. So it is not only 1g, but plus something. Of course, there are some coefficients of the safety. You don't. It's not enough to cross it by 1 gram to exceed the real limits of the robot. So yeah, it will not really break the robot by that value. So there is some margin of the change. And as I also said, okay, the max payload is something that you find in marketing leaflet, not in the documentation. In the documentation, you will usually find an information of it will not be one number. Usually you will have like a graph of how far from the tip or from the flange the center of mass can be, and the farther the center of mass is moved from the flange, the lower the load can be. So that usually looks like that. So you have the max load in here, and there is you get a graphics like X and Y from the flange, and you have the limits of, let's say, 5 kilograms, then you have like 4 kilograms, and so on. And that's something that you in fact find in the documentation. So those are just, so the example is just a simplification of all the problem. Okay, but that's something that you need to remember. If you want to move with high acceleration, you need to use this information when you select the gripper. So your load is not only the static load, but also the part that results from the movement. That's also something that you need to use in some applications that use specific grippers. We already talked about it with one of the groups that does the FANUC project. So when you have especially when you use the force enclosure, okay, maybe just return to that after you make an example with the force enclosure. So what changes when you have the force enclosure? So we have this block, and we have just a standard gripper of that shape. And we want to move the same object with the same parameters. So what force we need to apply here to the object in the gripper clause.
Okay, got it. So I will know if I am on the right track.
How to calculate it? Again, we are moving this 0.g up, acceleration. So we already said that we can treat it as a 1.5 virtual mass in the static case. we have this 0.6 coefficient, 0.6 coefficient of the friction. Sorry. So what will be the force, the clamping force that you need to use?
Learn English. Learn English.
So what force we need to apply in here? Let's call it FC.
For me.
Any idea how to calculate it?
Expect, of course, project, right? Except project. We are talking about.
What we know about this friction force in here?
Right?
This friction force will be like
so, professional development for sure.
Sorry, this friction coefficient multiplied by FC. Okay, in fact, we have, because we have two fingers, so we can say, okay, that that's for one finger, that's for another finger. That's how we calculate. We need to get this N force must compensate this 15 newtons. So we need like 7.5 Newton for each N, N1, let's say N1 and N2. Let's say it's symmetrical. And it's equal that value. And to get the proper friction, we need to divide it by 0.6. Or, in fact, when we so it will be like more or less 12.5 Newton. Or in total, when we look at this clamping force, it will be like 2.5 kilogram from both sides in total of the clamping force that we need to apply. So 125 from each side. And it will be just to be at the edge of this movement. And if we move a little bit faster, the object may slip out. So that's what happens in here. As I said, we need to use that kind of the calculations also in other type of the grippers. So when we say about the vacuum grippers, so they have these suction cups in here, and we get the force that is applied in that direction, and we can easily calculate of how the what should be the force applied on that side to compensate the gravity part. But you need also to remember that if you start to move to the side, the force that you apply in this direction does not compensate this one, and then you only have a friction to the side from the caps that are connected, and you need to be careful if too quick movement to the side with the object will not break the connection at the tips. So those are all the details to be considered. So you need to be aware that selection of the gripper is not really that easy thing. You need also to make some considerations, consider of what movement are planned. So not only the static situations of what is the mass and what is the object, but you also need to think in advance about the motion that you are going to use with these objects, and what you are going to do, what accelerations, what velocities you are going to use during the movement. Or on the other hand, when you already have a selected gripper and you are just preparing a program, you need to limit your movement and to add some constraints of the movement, not to exceed certain parameters. So either here, not to move too quickly up, not to lose the connection, not to move too quickly either up or to the side, not to lose that connection. So there's always some, at least rough calculations that you need to do to be sure that everything will work correct. Okay, so let's also look on how the grippers may look like. The mechanical grippers, probably when you want to, I just made a selection of just very simple types. If you want to find out more, there's a book, Fundamentals of Robotics, in part 2 by Morecki and Knapczyk. You will find many more different mechanical structures of the grippers. I will just show you the 1 degree of freedom, some 2 degree of freedom solutions. So you have here just 2-finger clamps with the prismatic joint. And at that point, kind of the standard, very similar to the one that we have with the ABB robot in laboratory. If someone wants to see, that's this type of the solution. You can have a rotational joint in here with the fingers of that type. You can have the mechanism of that type when you have the prismatic joint in here, but and here you have a passive joint that is not actuated, so the movement of the fingers is rotational. Okay, so what is the difference? Here we have the prismatic or linear movement of the joint and linear movement of the fingers. Here we have the rotational movement of the joint and rotational movement of the fingers. Here we have the prismatic or linear movement of the joints of the actuator and the angular movement of the fingers. And similarly in here, that also linear movement here and the angular movement in here. Why there are so many different types of the grippers? You can think about the properties of the object that we are going to grasp. So, for example, if you want to grasp a ball, as we were showing on the picture, you can imagine that probably the first one will be better than the second, because in the second, if you don't grasp the ball in the correct place, okay, anyway, always when you grasp the ball, it will be the forces that you apply will be in will not be parallel to each other. So the force will have here. So they are not in line while grasping an object in here. You have the forces that are in line. We will go into the details of the grasping forces and what happens with the objects on the next lecture. But when you think about the calculations that we did on a previous slide, in this case, when you need to calculate the friction that is needed, of course, imagine that the object, that the gripper is keeping the object from the that is let's say oriented to the downside, so the gravity would be in that direction. That in these situations you will need to apply even bigger force than in the situation from the first one. So that's one of the properties that we get here. What else? So the difference in the contact force direction that can be better for our application or worse. What else? When you have the force that you apply to the object in this place, you also have the, of course, from the Newton rule, you have the force that goes of the same size. Okay, it didn't doesn't look the same, but it should be the same in the opposite direction that acts on the gripper. And when the gripper is connected in that point, in fact, you generate quite a high momentum. As you remember, that is like a force that is here, like a reaction force, time the arm of the force that will be that long, and of course the sine of the angle in here. But anyway, you get a certain force that does not act in the direction of the actuator, but it must be compensated by the structure, the mechanical structure of the gripper. So if you try to apply too high force in here, there is an option that something adds, trying to change the orientation of these clamps. So that may be not so good for the for maintaining the proper grasp and for the long-term usage of the gripper. Similar in these situations, when you apply a big force in here, you need to use this at this momentum, and there will be some bending force that is applied to the fingers. Of course, you can use this bending force for the grasping itself, as we've seen of these resilient grippers on the video. That can be useful, but if you want a rigid gripper that doesn't change its shape, this force is maybe something that you do not want. So then you can look at the third example. The force is applied in that place, so you don't need to apply it that far from the contact point to compensate. Here, the distance between the place where the force is applied and the place where it is applied to okay, the force applied to an object and the force applied from the actuator, the arm of this force is much shorter, so the influence on the let's say the bending force to the clamps and these negative elements that can possibly destroy the gripper are much lower in that case. And similarly in this effect is used also in this situation. So those are the elements to be considered by the mechanical construction of the gripper. Of course, for us as the electrical engineers, that may be not so interesting, but it's good to be aware of such an effect, of why the selection of this different type of the mechanism may be important, especially if you think about applying high forces that may be needed for certain objects. Okay, and here you will see even more complex more complex mechanism with the parallel graphs of different parallel structure that we have. You can see that even still with the 1 degree of freedom, the mechanism can become quite complex depending of what we want to achieve. Okay, on the resilient and elastic fingered grippers, we already have shown how they look like. So generally, the calculations of what happens with them is quite complex because it requires solving partial derivative equations. So it's not so nice as the rigid grippers when everything is solved using just geometry and kinematics. So it is an interesting subject, not so often used on the, let's say, industrial level, but in certain applications, for example, in space manipulator, the elasticity is used quite often. And as you could see, there are some applications that the effect can be quite interesting.
Okay, that sounds very good.
Okay, so those were the main, well, the standard approaches to the grippers, but I would also like to show you some special solutions. For example, the adaptive grippers. The adaptive grippers is the idea that can look in real schematics as we have on this picture, and I will show you in the video in a while of how it works, but just how it works at the geometric level. We have the multiple parallel mechanism, and this mechanism works like that when you try to apply the force to a different shape of the object at different the object that contacts the gripper at different locations, the shape of the gripper or the finger of the gripper is automatically fitting to the object itself without special actuation. So what is important, for example, in this example, the movement, you can see that the object is in fact enclosed with the fingers in that shape in here, but it is not done with the active joint. So we don't have here three different actuators to move. In fact, it is done only passively with a single degree of freedom. And how it really works, as I said, we can see on the video. So just switching to the video right now. Okay, let's start from that point. So that's how this parallel mechanism works in practice. As you could see at the beginning, that this the solution from Festo, so it's from the company that produces quite a good industrial grade solutions. And that's the types of the grippers. Here is the 3-finger gripper. Again, if someone is interested to see how it looks like in 010 laboratory, we have the 2-finger gripper with that type of the fingers as well. So you can see how this gripper works.
And I'm asked about this because this is the future of military right now. The drones, royal groups of drones that are able to cooperate, and do surveillance, how you call it, reco.
So objects. That you can see how the shape of of the gripper fits to the objects automatically.
If you will be, of course, approved, recovered for that. Yeah, you as a Ukrainian, you have the competencies in the you have motor siege, which produce the engines for flying machines, let's say, different names. For rockets.
Okay. Okay, so this is the type of the adaptive grippers that, as you could see, what you get with them is the possibility of having this form or shape enclosure just with 1 degree of freedom, which is very good good property to use. Then we have the another solutions that are hybrid, connecting different approaches, and what you can see here is a kind of the solution of the problem that we are showing for these vacuum grippers on the top, that they keep the objects, but when you want to move quickly to the side, so you have this vacuum gripper at the center like that, but also you can grasp the objects from the sides. Maybe you don't really apply the full force to keep the objects, but at least that enough force not to compensate the side movement, side acceleration of the object during the movement, and that is the purpose of such hybrid solutions. So you have one force that goes here and another that keeps the object in that directions. So that's also is available as a solution. And the third of the interesting options to know is the dual grippers. Then you have 2 grippers on the same arm. The question, why to do that? So usually you get these properties. First, the shorter cycle time, then you can have increased grasping payload, just because you can often see that while the manipulator has like 5 or more kilograms payload available, the gripper itself has, let's say, half kilogram or 1 kilogram. So, and if you want to carry a bigger object, you may want to have more grippers connected. But of course, you have decreased overall payload because each gripper also has certain weight, and that decreases the overall payload. You can have grasping with more contact point, yes. So you can imagine a situation when you want to pick a very long object, you may want to grasp it not just in one point, but in several points. So you would prefer to have grippers on each end instead of one gripper in the middle. You can also have the handling of different type of the object. So of course, the situation to the left on the picture, we have the same type of the gripper, but you can imagine that we have 2 different types of the gripper, and depending on the object that we have, we just switch it. But the picture to the left is in fact using this property, because most likely we'll not keep one object with this and not different type of the object, but we will try to reduce the cycle time. The question why we get this property of the shorter cycle time. Imagine such a standard situation. So we have the conveyor somewhere, and we have an object, and we have the machine that we want to put the objects to and the robot that uses a single gripper. So how the process will look like? You will need to take an object to the machine, wait here.
From the language perspective,
So
sometimes I may just
let's call the place A and B. So a single gripper.
Should I be very careful about that?
Operation will look like that, moving the object A to B. Then you wait.
I know how you build the psychological.
Then you need to wait for the object being processed. Then you take the object back to the line, and you start operating with the second object. So that's the object 1, and here object 2. Generally, you need to wait here in that situation. What will change if you have a dual gripper? You can